Hey, hello there. Let me fool with my levels a little bit because we might be too loud for the day. So there we go. Okay. As always, I don't want it to be too annoying, so we'll dial back the gain on this microphone just a little bit and make up for it with loud drum and bass noises, right? That's what we want. So hello, anybody who shows up. We are coding ZLowpass. So let's get ready to do that. Boop. So here's what we got. We'll be working from here and probably starting off with cloning what we had in ZBandPass and altering that. And I've set up a little example for today. Here is our target. So that's the heavily distorted drum track. One of the things of interest here is the way that the gain works, and I might need to do a little fiddling around to get that dialed in right. You can pretty plainly see here on the screen that my lowest frequency stuff, this is actually a little boosted compared to the mid-rangey stuff. It's always a little bit different each time, it seems. So this area, the source material is always, hey Bo. The source material is always this drum loop that's distorted to the point of ridiculous. And as you can see, this is a mid-rangey one. But you'll notice that when it's at an extremely low frequency, that's peaking hotter than here. And I'm not entirely sure what's causing that. What's causing this added looseness in the bass frequencies, but it's very plain that both the high frequency stuff and the super low frequency stuff, that's peaking hotter than the distorted mid-range. And this is the raw output of the real sampler, and I'm giving it the most distorted drum tracks that I possibly could. So these variations, hard to tell, it's not necessarily interesting to tell whether it's coming from DSP or whether this is the analog outputs of the system doing it. All I can say is I'm going to need to make my stuff work this way. can have a look at some of these peaks, see what we've got in here. See what's interesting? I see where this is clipping. These waveforms want to clip around here, but something's going on where our low frequency resonances, and you can kind of see the characteristic shape of these resonances. This is way down in the bass, but you can see where this would be where the underlying waveform just hard clipped. And you can see these shapes, these consistent shapes at slightly varying volumes, but the curves are about the same, and that means this is a resonant, this is the 4 dB per octave. It's a resonant low pass, and that low pass is putting out outputs hotter than the underlying distortion of the digital stuff. So in other words, one thing we can establish here is the headroom of the DSP calculations and the output of the resonant frequencies is hotter than the headroom of the digital signal going in, because this sound, at various different scales, you can plainly see what's going on there. The underlying sound here is just completely digitally flat-topped. It's distorted beyond all recognition. So what we're going to be doing is taking the, and here's another example, this also clearly looks like digital distortion. And we can see where it's distorting, and we can see where the equalizer is causing these sort of attack peaks on here. It's following the swing from one side to the other with some overcorrecting, which is resonant filter behavior. And that strongly suggests also that we're going to have a similar resonant behavior to what we had in Z bandpass. In fact, we might be dialing in the exact resonant frequency to get this result. Oh, is my mic distorted? That's a shame, because it shouldn't be. Is it when I'm talking too loud or something? Because it's not showing as distorted here. Yeah, I'm not seeing clipping. I can, however, I'll back it off just to here as well, because I don't mean to make it be super loud. And yeah, maybe that'll help a little bit. I kind of have it set up so that I can talk at a comfortable volume and still be coming through. But, you know, on the meters, my regular talking is not distorting like crazy. I can check the recording later and see where I got. So, let's jump right in immediately so that I can walk through some of this stuff. To some extent, I may be able to talk while doing it. It's always a bit of a challenge. With luck, what I'm doing here... Oh, well, I can't hear it, so I'm sorry. It's this little clip mic. And it's... I don't know whether maybe that would have fixed it. Yeah, Stan, I can't hear what is going through. That would be I can't hear what I'm feeding the audio with, so if the microphone is completely broken, I won't know it until afterwards, and I'll find out by there being 0 viewers. So this is, hang on. But if I do this, how are we doing? I just changed the connection, and if that connection was bad, that might have done something about it. So yeah, there's only so much that I can do, but let me know if that made stuff any better, because that's the deal here. Is I have the microphone was actually working before. Oh, well, if it's not a big deal, you might be just complaining about the sound of my lavalier mic. I'd like to check it out, but I can't. I'm sorry. And I can't let that distract me because I have a plugin to code. I'm seeing some kind of energy buried way down at the noise floor, but we'll see. You know, if it ain't one thing, it's another. Oh dear. Well, I don't have to do a plugin. I can do a mic fixing stream. Excuse me while I fool with this for a second. I'm going to go dead for a moment. Okay, back into the audio. I don't know if that did anything, but I flipped some of the switches in the amplifier part, and I was able to patch it through for a moment to the iMac speakers. And what I heard some of the bad tone of it, but I'm not sure how much of that is just the lav mic. Yeah, you can't hear me because I was patching my microphone temporarily through into the iMac speakers so I could hear what you guys were talking about. And I did hear a certain amount of not likey tone on that, but I'm not sure how much I can do about it. We'll go forwards from there. That's all I can do for now. There's no way that I can patch through, and I don't own another microphone that's suitable for doing this with. So we'll see what we get, I guess. One thing about it is that the metering seems to be showing the general levels being okay. So if I've got like bad crunchy noises, it might be just a matter of my patch bay or something. My stuff is patched through a patch bay at the moment, and that could have caused problems. I'm telling you, some days are worse than others. The other day, I was fooling around with stuff over here. Oh, how bizarre. Hello. Okay, I think I see something. I have audio from the microphone that's actually also connected. I think I can fix this. Do you see what's happening in the background here? Because this is a really weird effect. I bet I can fix this. Check this out. My patch bay uses these cables to run into the converter. And I've got it currently patched into something. I have a WMD SL3KT. It's a switcher. And yeah, this patch cable is getting the output of the preamplifier. See, I'm figuring this out on the fly. And for a change, I've got it patched into something. It is pushing so much energy being patched into the output of this Eurorack module that it's lighting up the indicators. I'm not sure if you can see this. It's lighting up the indicators when I speak. That's what's causing this distortion. And if I flip this switch, I'm lighting up the indicators in green. If I flip this switch, I'm lighting up the indicators more easily in red, and none of them should be getting lit up at all. And if I unplug it, suddenly we're not going to have the nasty distorted quality. This was the problem. This is what it was. So let's put this politely over here for the moment. In fact, maybe I'll put both of these just in case I need to use the other microphone input. All right, problem solved. That's interesting. I think I had that patched all for the video that I made. So the bandpass video, the voice is messed up more than it should be. Yay, very interesting. I knew it was a mistake to try to do that patch bay. With a bit of luck, it'll make things easier in other ways. I'll see whether I'll use that patch bay just to have cables sitting where I can reach them, and maybe use the Mo2 as the correct way of doing it. Very interesting. You know, they say never turn your back on digital, but yeah, never turn your back on hardware either. I didn't realize it was going to do that, and I put a lot of work into putting that patch bay together too. Maybe it's all just fine. I will just figure out what I'm doing. And the problem with the Mo2 is that to plug stuff into the back of it, I got to reach around behind it and plug it into where I can't see anything. And that's a big pain in the butt. Unless I come up with some lovely fancy way of flipping it up forward so that I can see where I'm plugging. The patch bay was supposed to fix that, but it doesn't actually unplug the thing that's the cable that I was showing you. All right. Well, hey, actually managed to fix that one. Cool. Where was I? ZLowpass. So I've got the version name already figured out. We're going to want to fill in this stuff. And as from before, I'm going to want to, yeah, I can't believe I did the entire bandpass. I wonder how that even came off, because that's a very different microphone, and it might show the distorted quality differently. Or because no, it would be about the same, because I was patching it into a Logic project, which is how I make the plugin videos. It was a short video anyhow, so whatever. Now I know not to do that for future reference. Here is ZLowpass, so we're going to go in, leave all of these controls here, but update this stuff. And that also means I can copy and paste from here to not type those things. And we'll blank this stuff for the time being, because these are the ones that I might want to use dialing in things by ear. Because a lot of the time I'm finding, especially with doing this kind of thing, if I'm trying to get a sound, it's too slow to go in and like write different code and then recompile it and then try it. Hello from Russia. That's not a very sensible question, so I can't really answer it. You should know what I do if you're asking questions, because that doesn't make any sense at all. Maybe I'm being unduly harsh. Yeah, this that you see on the screen, this is the stuff that I do. They are all free. They're open source code. You can have any or all of them. You may or may not be able to work out what it is that I'm building. You'll see soon enough. I promise I will be starting to do this stuff, and you will see what it is soon enough. Here's our biquads. We need a whole set of those, and we need the IIR filter for the op-amp emulation. That's our H file taken care of. Now once I've got this taken care of, I actually have something that will build. So let's see, this stuff we're going to want to keep, and that stuff we're going to want to keep. But I need to plug this stuff in. Excuse me. We'll go from here, and let me see. It looks to me like this is what we're going to want. I'm just going to grab this and tuck it away somewhere. Like here. And then I'm going to take everything. With a bit of luck, this should get us results real fast. That's what I'm hoping anyhow. So now we have ZLowpass. And this is making it low pass. Except for we gotta change this a little bit. I think I'm down with that though. This part is the part that needs to be updated, and this is what needs to get punched in here, because this was another value for this stuff. And we're not going to necessarily want that. Instead, let's actually go with, we'll immediately go with putting in a control. This is the resonance for this filter. And if we make it be 5 and make sure that we don't actually have it set up, well, hang on. I can make it default correctly. Starting to get into that zone where I'm not talking sense. Bear with me. If 5, which is our Q factor for the moment, is 07071, that's Butterworth. That's not necessarily what we're going to want to use, but I have a number of things in mind here. One of them is, hang on, making sure that that doesn't start out as a 0, which if I run this program, and this needs to go away. If I run this program with this calculated on biquad A1 equaling 0, I think it's probably going to crash. Yeah, see, it's a divided by, so that won't work. So we have to be sure never to move this control all the way over to where it says literally nothing. But we also need to see how much resonance we need on this and whether it's giving us the right kind of result. And the easiest way to do that, let's see now. Let's see if this builds first of all, because that should have been everything. That should have been everything to make it be a buildable thing that will technically be a low pass. We just don't know whether it sounds anything like what it's supposed to. Here's our little window. Here's our buildable. Hello. Can you not drag? Yes, you can. There you go. There's our older item. Here is our audio track. And if we fire this up, we'll get something out of it. The question is whether it's the right thing. Oh, no. Q should not be 0. That should have started out as something, but I guess I had it set wrongly. Let's see if that killed it already or if I need to play in order to start running audio through it. So the gain of 0.1 was the previous setting before I changed stuff around, so our gain levels are going to need some adjustment. This is dry. This feels like it's not right. We've got way too much area over here in the frequency control dedicated to super low frequencies. It was not voiced that way. We've got our usual brightness in the highs. It's getting louder there. And we've got a certain amount of additional boost in the lows, but the frequency control is not configured right. And one of the things we're doing is fooling with the Q. I want to see whether I can make it peak out much hotter. Like, can I increase this Q value and get a bigger boost on the low frequency stuff? So here's something that we can do right away. Now, if the control is set to 0, it's going to be a Butterworth filter. It's going to be no resonance. And clearly we have some resonance. So what I'm shooting for is I want to see whether or not the resonance gives us big boosts on the end of everything. Because again, when we distort everything like crazy, the actual hardware behaves in a characteristic way that I'm trying to get right. Now that the voicing of it, the way that it sat relative to where the slider was and relative to what was in the extreme lows, this is the real thing. As you can see, it's peaking up into the red there. As we go up into the highs, it's a little darker. Lows, we've got this big boost there. Mid-range sits there. So we got this big boost in the lows here. And the extreme highs have that brightness boost. This is what we're going to try to emulate. Because the thing about this, and one of the things about coding a plugin of this nature, sometimes you have to deal with listening to the same thing over and over because you're listening for the variations, especially with something like this. And the reason I've picked this particular thing and the reason I've picked heavily distorted is because I know that's one of the things that folks do. Oh, you don't get a slider for controlling the resonance itself. What you get is poles. Poles is not exactly controlling the resonance. Poles is shifting between this, which is the 4-pole, and this, which is the 2-pole. That effectively controls the resonance, but it controls it by doing additional stages, and that's what the original sampler does. Except for the original sampler only gives you 2 options. This or the more resonant one. And the pole slider in the Airwindows Z series lets you interpolate between those things. You don't get a dedicated cue for the biquad because that's fixed, that's built into the way that it does what it does. So I would look to the poles filter for what you're talking about, especially considering that it has the dry-wet control built into it. The whole point is to get the actual cue factor built into these things to where it mimics these at the appropriate settings. Settings being like poles should be at about 0.5 for the first one and cranked up all the way for the second one. Or maybe more like 3/4 of the way, hard to tell, but we're targeting this, and let's see, I was talking about the way I was moving the controller, the modulation wheel that gave me this sound. I was moving a modulation wheel kind of steadily going back and forth. Just more in the middle. Right. Dark. Right. Dark. So what I've got currently in the plugin is leaning far too heavily on the lower range. Like the lower range seems to be emphasizing the super lows way too much. The entire bottom half of it seemed to be sitting around in the bass, and that's being caused because this is where that setting comes from. And the way it works is we're using this power factor to very accurately, because using POW in C and C++ is apparently a much more accurate calculation than just multiplying things multiple times. I can do this, and then there will be less emphasis on the low frequencies in the controller. It's also worth looking at, I'll be tuning these things. And as such, it might be worth me setting some of this stuff up. Clip factor, if I'm not mistaken, is what is boosting the lows every step of the way. We're doing input sample divides equals clip factor for each of these, so we could dial this in again. And for me to do that, let's first build this. See how many of these things are closer now. And then I'm thinking we're going to put a bunch of these things onto controls so that I can sort of quickly bounce back and forth between the plugin and the real one and see what it takes to dial in where the extremes of that control is. Because currently we've got this. We don't need this much resonance. So this would be Butterworth. This would be around 1. And the idea is I need to dial in the frequencies so that when we're down in these low settings, here's one of the things I wanted to check out. Okay, so full crank, full bright. As usual, my stuff is a little bit brighter in the upper midis, and the real one's not quite as loud up here. And as we go down into the sub bass, this is arguably lower than the real one goes. I think they're each sort of sculpted to the desired purpose, and that's what I need to do. I need to replicate what the sculpting is. But firstly, this is peaking at this hot, and you'll notice that when I say Q and make it be Butterworth, oop, no, that's just the volume control. What am I doing? Hang on. Too many little knobs everywhere. If I use the frequency control, it's actually getting quite bright up here. And then as we have it way down here, with the low Q, with the Butterworth Q, we do not have the resonant factor that we originally had. Now when I dial in a little more Q than Butterworth, a little more Q than just smoothest possible roll-off, we're getting more gain out of it. And also, actually, no, never mind, we are still incredibly loud anyhow. So let's not worry about that right now. Turn the speakers down just a bit. So yeah, poles at 1. My output should be controlling this though, and it seems like it isn't. Let's see whether we have an even bigger problem. No. They seem to be able to pad it enough. So we'll say that's about as loud as it was. With Q of purely Butterworth, we have it peeking out this way, but then as we turn it way down, our resonant frequency is just not as high. I couldn't possibly have put in that change already, could I have? No, I couldn't have. But then as we start adding Q, the resonant frequencies will start causing the lows to spike louder. And the correct lowest setting is going to be somewhere around here, if not higher. Maybe it'll be as high as this. So we definitely don't want Q this high, because that no longer sounds like the sampler. But we don't want it this low either, because that no longer sounds like the sampler. So there's going to be a correct spot in here somewhere. So that'll hold us for the moment. I think it's about time to start throwing a bunch of more controls in here. Oh, I keep losing viewers. Well, anybody who is hanging out, have fun. I'll just continue doing this. People can catch up sometimes listening to it or watching it later, so it's all good. Oh, one thing I wanted to do though. I'm putting so many of these things in. Wait, I don't necessarily need to assume. Here's my thought. Now if I start this up, anything that I had set up that would break if it was set to 0 will not break. None of these actually apply to anything yet. But if they did, and I had it in a way where the thing going to 0 would kill the result, it won't kill the result, and I'm free to readjust it as stuff goes forward. So that's what I needed to do. Now, on with this. What's my lowest range? F lowest and F highest will be useful to have. And I feel like I might also be looking into clip factor, because clip factor is a matter of turning up the gain more. So if clip factor is 1 minus get param 2 times 0304. Well, if that's turned up all the way, get param 2 is 1. If it's turned down all the way, get param 2 is 0. So it's 1.0 minus that. Bottom line is that's making stuff be louder when it's in the deep bass. Oh man, people are flying away like crazy. If the stream is completely broken, I apologize. It says excellent connection, but I can't necessarily go by that. Some days there's just nobody watching this programming stuff at all, and that's fine. It's possible that when I cough or choke or whatever, it hurts people's ears and they run away. I don't know. not really my concern. My concern is getting this right so that you can have it this coming Sunday. So let's see, I have a F lowest, F highest, and then we'll call that lows boost. And let's just go in and set it to what the end result is going to be. So we're going for this, so let's go and set it to that. That way it'll be ready when we start. Lowest, highest, and 0.30, what was it, 4? Yep. And rather than being get param 5, which is being reserved for this, that one's going to be 6. This, let's call it seven. As you can see, I'm going to make that one go from 10K to 20K, and we're going to find out what the desired result actually is. Hang on, did I just tell that to be 7 or not? So that's 6, so this one becomes 7. And this is the one that we just updated. And that's going to go straight to get param 8. Now let's see whether we can get this in the zone. Oh, I did a wrong thing. Let's see whether that makes it work better or whether it just breaks and dies. That was probably what it wanted. I probably missed the closing parentheses for this. It's a little difficult to tell which one goes where. And that one goes there. That one goes there. And then we've got the one on the very end. You end up fooling around with all these different parens, because they're like explicitly spelling out which math operations happen where. We'll build that, and now some of these things should be sitting around much more accessible. Make sure it still works. F lowest, And remember how we just did the lows boost? Well, less lows boost, more lows boost. So one thing I am wondering is whether I even have the correct setting for this. Here's our dry. Here's our sort of raw output. Hey, Jazz. And then that low might be fine. Like this low end might be a little past what the real one is. Let's go and recheck that again. Here's our real one. Yeah, we're not too far out. There's the real one, and if we go back to F lowest, one thing about this is I absolutely am not getting the volume ducking in the mid-range that the real one does. I'm a little concerned about that. Let's go and check out the real one again. So that's not all that distorted, even though it's quite distorted. Is my screen flickering and everything too? You know, one reason that happens is the video thing is overheating. Yeah, that's the video thing overheating. The Blackmagic design thing needs to have ventilation, but I may be able to hack it just temporarily by pulling it out and flipping it over on its side. This needs to behave as if there's a little chimney. Let's see if that makes it any happier. I took the video thingy and flipped it over on its side so that hopefully convection will pull air through it. If that don't work, I'll simply have to go and make a fan for it or some kind of convection thingy. Yeah, like I can feel the bottom of it and it's heating up like a bomb. These summer days, the Blackmagic gear doesn't like that stuff. So this is what we're trying to emulate. This has been a really bad day for getting distracted by technical problems, I gotta say. We're trying to get this tone. Now, we're trying to get that tone out of this. already too much Q. Or is it? Lows boost is kind of key here. Like, we don't want this note, this drone. Well, blowing on it is not helpful. I need to make a fan. I can't do that right now. If the Blackmagic video switcher fails on me, it just fails on me. Sorry, guys. So, no Q, too much Q. So what I'm really interested in here is figuring out whether I can get a characteristic tone out of the distorting it. Here's our really dark stuff. So when we get brighter, it stops grinding quite so much, I think. That's fairly bright, but not super bright. That's super bright. Hey, dude. So what we need is for this boost to get distorted down here in the lows, but it also needs to clean up as it gets higher. And there is a thing that I can do that might cause that to happen a little more. Clip factor comes from here, but clip factor could be, because making it smaller, so let's see, where are we going with this? If clip factor is larger than 1, then we are turning down, we are distorting less. If we're distorting the insides of the biquads, we're more likely to get the weird grungy quality that the sampler one has. In order to do that, we need to do this clip factor calculation in such a way that high frequency settings, where get param2 is large, are causing this whole thing to be larger than 1, because less than 1 is causing gain. So we can start by doing this. After all, we've got it set up so that (1.0) minus get parameter param2, that ends up being 1 when the control is at its least. And then we multiply that by param8 to have the maximum effect, and we can turn it up to the point where it's more than we need. So if we just increase this right here, that means the high settings, 1.0 minus 1.0, will have the least effect on this. And let's simplify this a little bit. I don't know whether my Q is actually going to be 1, but we can find out. And it's simpler than basing it off of the Butterworth, because I know Butterworth is not actually what we're going to want. Build, bring, run. Back into the breach. So yeah, that makes QB 1. So there's our brightest output. Here's our darkest output. And as you can hear, we can make it go smaller and smaller if we want to, but we're shooting for the actual thing. You know what? There, that feels more like mid-range. I needed to move the top end of the range. There's the bottom end of the range again. I could give it a little more to go, but we're probably fine. And remember how I was changing stuff having to do with Low's boost? Meaning that this can be less distorted, and this can be more distorted as I increase this control. There we go. Distort less, more enthusiastic distorting. Now the question is, do I want even more gain in here? I think the answer is going to be yes, because this is starting to get us where we wanted to go. So we're going to expand it even more. There's our resonance control. That's going to be fine. We're going to be able to find the correct setting there. Clip factor is where we were getting our mojo. We can turn it up to the point where it is more than we need, and this is giving us a range where the high frequencies are increasingly more cleaned up, and that means the low frequencies get more distorted as we turn this up, and increasing this number means we have more range to increase this factor here, which will clean up the mid-range a little bit relative to when there is deep bass in there. Now the other possibility is to try to incorporate biquad A0, which is a very different calculation. I'm not sure that's correct though. I think maybe I'm not going to worry about that one. So let's go quickly and see what we've got. One of the things about this I sort of vaguely remember, with some clarity really, what the original sound did. And when I say original sound, I mean this. So if I'm working with this, I have a vague sense of it should be able to do that. It should be grinding about as much. And that was the highs up there. So if we take this, which is the same audio clip, and do the same thing with it, aha. So you know what this means. Even that little change also needs to be on a slider. So what shall we call it? That was 0.5 that we settled on. And oh hey, we can make this say exactly 0.5. So it's slider 9. So if we quit out of here, we can have the adjustment to the adjustment to the adjustment be also on a slider. See, this is where stuff gets kind of fun and silly. And this is where I really start losing my words. Pulse trim. We're getting increasingly abstracted as far as we go, but if we can dial in just the right behavior, that saves a lot of time. So let's see how far we can get with that. That's parameter 9. So there. Now you saw how we had the gain there, and then we cranked it to 1.5 and everything was so quiet that it didn't even do anything. Now we can adjust all of those things. We've got 3 separate parameters adjusting this factor. They're all going to settle in to an area. It's built. And we're going to fire this up. We're going to fire up our low pass. This is the thing that we had before. This is the boost factor, which increasing gain as we go down in frequency. This is the trim, which is overall behavior. And here is our target. Needs to act like this. See how it's only peaking so high? Darkness. And then the brightness goes up yay high. We can also fiddle with the output levels to get that result. So, full bright. That's quieter, so we're on the right track. And then that's much louder, so we don't need as much of this boost. See how we can make it go quieter and louder? There's our full brightness again. Our F lowest is just still too low. Back into the breach. One more fiddle. We'll dial it back halfway. Two times get parameter param 6. That gives us twice as much effect. And then if we set that to 0.5, it'll come out to the same thing. Back in we go. Now, one of the things I'm also very interested in studying is whether we can increasingly distort the insides of the biquads to get the result that I want. See, and now it's not loud enough, so. And that's because F lowest went from this to this. And we're trying to sort of find where the range is supposed to sit, which is done by listening to the real thing. That's as dark as it's going to go. I'm also listening for the tone a little bit. I'm interested in whether there's any weird qualities that have to do with overdriving the biquad filters inside the whole thing. Because that's the hope, is that some of the weirdnesses in the way this is coded take effect. About there. Now, is it slightly more? Interesting. And our output is a little hotter than the way it's recorded. Hey folks, check it out. We're starting to get close. There's our lows. It is indeed peaking louder. Our highs are still good and bright. And this time, our mid-range is much like the real thing. It's dialed back. That's useful. Also, this sounds cool as hell. The question is it accurate? And if it's not accurate, what can we do to make it be more accurate? And sorry for everything flashing. One thing, I could take away the view of the screen and that'll probably make it better. I think if I just do this, it'll stop flashing. I'm not sure, but it's because this guy is overheating, as it is wont to do. Don't mind me, I'm trying to figure out whether I can stand it on something. Signs point to no. Get a little laptop cooler or something. Well, I can stand it on some pens. That gives a little space and a little air circulation. We'll see. It's not helping. I don't care. Got work to do. So that sounds cool. The question is it accurate? I would say no, that's more resonant than I need. So let's go back. Okay, what if we do actually want Butterworth after all? Real thing. And if we try to do that with this one, it does this. What would I get if I had literally exactly Butterworth? Like not one, but literally Butterworth. It would be that plus 0.5 is exactly Butterworth. And that's more loss boost than we maybe need. One thing about it, we're going to be getting the same kind of behaviors. You're going to get that low rumbliness going on. Alrighty. Yeah, it's feeling kind of like we're in the zone. By the way, if the screen flashing bothers you enough, I can just switch over to main camera, and then you just can't see what I'm doing, but it will stop the screen flashing. At least it probably will stop the screen flashing. I hope. Okay, needs to be there. We're a little louder, we're a little hotter, but that's going to be fine, I guess. Over to here. And this should be a little louder maybe, but it feels about the same, and I'm pleased with that. And here's bright over to super bright. So this is an area of interest. And again, if the flashing bothers you, I can kill the view of the screen. Hello. This is the area that's supposed to be flat, and it's kind of flat. And then as we go into the zone that is extra bright, it really comes forward there. And if I try that with this one, and then if we go over to output, again, more gain than we need, but Now we didn't actually compare to the two-polar. So before we fool with this, let's confirm the two-polar. That should be there, and this will be here. And this gives us a lot of brightness. But it might be correct. Yeah. Like with this one, it's not peaking as high on the low frequency end. It's being kind of stifled in here. And then as we get loud, it gets really aggressive. So, what have we got? One thing we have is maybe too much of this. So my question becomes, where is that happening? Input sample divide equals clip factor is what's causing that to happen. And we've got that going on over here, so let's move this. Or possibly just remove it, but I think maybe moving it might be good. Quit out of here. Quick build. If this is too much of a change, I'll experiment with simply removing it. That, or maybe, I don't know what we're doing. That'll either have helped or not. Yeah, that did the opposite of help. What if we did two of them? We keep having to do this adjusting and stuff, so... Or no, wait. One before and one after the op-amp clipping, just in case it works. Let's see what we got. If that didn't work, I'll take off that change and we'll dial it back to what we had, which was working with the high gain. Okay, so far so good. What about super high gain? One too many. So what does it feel like when we do this? Interesting. So here's what's happening. Clip factor is our gain trim thing. It's happening inside each of the biquad stages. It's also happening in the output of the biquad stages, and that's what's causing it to be able to go loud on bass frequencies and have that be effective. It's maybe not too optimal literally on the output of the op amp stage because there's no practical reason that would be happening. Might be just an adjustment factor here. Maybe instead of adding more of them, I'd take that one out and see what it acts like. Because right now what we're about is playing around with all of these pulse settings in order to try to get it so that it'll act correct both like this and like this. That's too loud. So the gain's too loud when we're at poles of 0.5. This factor corrects things for us. Putting it in after all of these is technically applying it. If we have it here, we're not applying it at all. We've always got to have at least one of these guys in here. What if we do it ahead of this happens always? These only happen at high settings. This happens always. This is the one that wasn't behaving itself very well. Let's see what we got. Okay, this is more what we want for behavior. Lows are getting kind of boosty. Highs are distorty. Mid-range cleans up. Maybe simply dialing back the sheer amount of gain. Boost trim is where we're getting sort of our overall slam. If we increase it, things will get quieter, like this. Yeah, we got a real challenge here. High pole settings, it's not that difficult to get it set up, but this 0.5 is super uncompensated. But we know what it does. So let's see if we can get it dialed in by increasing it more. After all, this does turn down when the frequency setting is super high and turn up when the frequency setting is super low. So we're just going to have our 5 instances of it. 1, 2, 3, 4, and 5. And that means that the setting with only one of these here, which is the 0.5 settings, will have 2 of them in there instead of only 1. And we'll see whether we can get it dialed in this configuration. If that does, it's probably as best as we can get. Use them on anything you want. You've already got the high pass and the band pass. I'm now trying to get the low pass happening. Use them on anything you please. They just have a built-in distortion box. That's the main thing. Okay. So we got a lot of extra gain here. We need to let it go a little bit right here. And reduce this. Okay, so far so good. We still have the voicing working pretty good. The question is, Alien Kittens is already done. Oh hey, this is kind of cool. A bunch of other plugins. Thank you, Fotis. I feel like this is one of the ones where I might as well have the output the way I originally had it for high pass, because this goes really freaking loud when the frequency is cranked up. It might as well be a straight up pad. Oh, hang on, that's not what I wanted to do. Let me recalculate that for a moment. That was the wrong thing to touch. 207. So let's see if we can get anything useful out of having more gain on tap while doing this. Nice mid-range punch. So if we cranked out the output, okay. I think that's probably a good enough reason to have that on tap. That gives us the capacity to have the output cranked, which we would not be able to tolerate under most circumstances. And bring in a huge amount of super low-end kick without actually distorting the input at all. So input, no distorting. Okay. Yeah, this makes sense. When you combine input and output gain beyond 0.1, things get out of hand in a big hurry. But this is giving us a super subsonic boost. Pulls into dark, into super dark. And we can pad it just a little in case we don't like how distorty it gets. Dry, wet, super wet. And if you're working basically from just dry, you can turn the output up all the way. Dial in something that's a nice beefy crunch. Like, where do we want this kick to hit? Can have it hit like there. And then you go from dry to emphasizing just that quality. And that's got some nice dry qualities to it, but it's got a real thwack going on. And if it's not enough, we can always boost a little bit. So there you have it. That's something we can do with it. So this is the raw microphone output. And then boosting into a sort of mid-rangey bassy frequency. Here on. Boosting into a mid-rangey bassy frequency with the output cranked and the poles slightly more towards the dry. Turns into this. That's beefy. That works. And now it sounds like a much larger bass drum. A little less. That is something that I would call a useful thing to be able to do. So like, I want the bass drum to sound and feel more like your John Bonham double-headed giant monster of a bass drum. Well, we do this. And more and more. And then this is the hypothetical exaggeration of that. I think that'll work. I think that'll work. We have a ZLowpass that I think is good enough for people to have. Cool. Cool. I will finish up the details by copying all these magic numbers over to the code and then making the VST out of it and all that other stuff. It's all good, I guess. I think it's all... that is acceptable. I don't know Lindell Audio. And on that note, see you folks. I'm going to let this poor video mixer rest for a bit as it is overheating again. And later I'm going to figure out how to cool it properly so that it doesn't flake out. For now, however, I'm just glad that I solved the problem with the microphone at the beginning of the stream. And I'll talk to you folks later. Bye-bye.